Okay, so our next speaker is Dr. Todd Snyder from the Union Pacific. He's Director of Advanced Freight Car Engineering.
I do have a great team, and we also have a quality manual, and it's how to integrate things. All right, we monitor wheel changes. That's one of our best metrics. A lot of metrics that we follow, wheel profile, anything that is automated, those are great metrics. But that's not really what drives our work. Our work is still driven by derailment prevention. 20 years ago used to be double digits in all these categories, and now it's single digits, and there's very little funding to continue down the road. So aside from the derailments, which has always been wheels, axles, bearings, maybe some trucks, maybe some coupler securement, we're really focusing a lot more on the operational side of things. And the operational side of things, outbound set-outs is something that we really track. It affects trains not getting into their slot in the network on a capacity-constrained business model here. So we want to go after those things. Derailments and outbound set-outs, pretty important. And so we did a little bit of a technical assessment. We have in the last 5 years or so as we've been figuring out what we ought to be working on. And from a derailment prevention capability standpoint, we're at about 54%, which means we have all these derailments, about half of them we can prevent. Maybe we need a few more detectors of this type or that type, but we have the capability to do it. Maybe a few rules need to be changed. But there's a 50% gap that we don't have the tools for. And the other thing on finding outbound bad orders, or any bad orders for that matter, our performance there is maybe 28% that is automated. The guys find everything, the inspectors find everything, but that's a really large gap if you're all talking about automated inspection and changing finders to fixers, and we'll talk a little bit more about that later, but that's a pretty big gap. So the things we're working on are trying to cover those two gaps. Air brakes is one of those big hitters for outbound setouts. I'm going to talk about that first just briefly. And obviously I've got a lot of patience because we stood this up 12 years ago, this cold wheel. You use a wheel temperature detector to look at the wheel temperatures. And it worked wonderfully. And we've been 12 years till now before we finally got this, an FRA waiver to say this is a better way of doing things, safer, more efficient than the old way of doing things. And we're being allowed now to bypass an intermediate inspection as long as we can guarantee that anything we find on this trip is going to get fixed. And we do that in the coal loop. We're doing it on the coal loop. It's a one-hit rule. The FRA really wanted, hey, it's either cold or it's hot. And if that's a problem, you take care of it, mark it off. And that's what we do. But the better way to do it is to lower the thresholds, find a whole lot more bad things, but deal with it on a statistical basis, because every car from time to time is going to have a hiccup. Slack adjuster is not going to do what it should do, or just something's going to go wrong. And if you're not effective in prioritizing what you're fixing, then you're just fixing more things. The good news here, I think so far, that we've determined that 4-port testing is twice as good as anything else. When we do that test and we fix it using the 4-port test, we're half as likely that car is going to come back in the next 30 days or 60 days or 90 days, because it's testing different things compared to the end of the car test. But the technology is very sound, and it's just looking for the temperature on a truck basis of these wheels being colder than all the ones surrounding it on the other cars. The value, again, is in doing something statistically. I did manifest trains, a little analysis the other day. Some are loaded, some are empty, some are 50 years old, some are brand new. You know, it's got the widest variability, and we're able to predict about 42% of the outbound no sets that are found. So, terrific technology. All right, another thing we're working on, this one isn't so much wayside, been going on for a long time. The first rash of broken wheel derailments I had to deal with, we started with running out there with a hammer and hitting the wheels and listening for the ring down, and that was followed closely by hiring a bunch of contractors to go and ultrasonically test by hand with a single sensor every wheel in the coal fleet, basically a triage. That was followed by the wheel shop UT, which is probably, I think, the biggest driver of derailment preventions that I've seen in my career. That process is good, and it went through a revision. It could still be better, but that's a fantastic deal. And then in 2010, we started doing the full train ultrasound, and now the technology's gotten better and easier to use, and we've rolled out this handheld UT, which is a little phased array unit inside a wheel that's filled with liquid couplant, and you can just run it over the wheel, and it makes a pretty picture, and it tells you if there's anything bad in the wheel. So UP's big believer in the ultrasound methodology. I think the CP right now is testing out the latest and greatest in that area, and we're also considering moving forward with a solid state device, but not yet, because we've got another idea, and this is where technology is really landing with all the tens of thousands of devices that we've put out there with PTC. And as I mentioned early on, how does everything integrate? How do we make sure that everything's integrated, take advantage of that? We've got an IoT, an Internet of Things, edge computing idea here that's really taken off. Wayside detectors are going to be around for a while longer. We hope that MOTS takes off and that every car has an onboard sensor on it with a check engine light, and maybe that'll come, but it's maybe going to be another 10 years, 20 years, who knows. But in the meantime, our wayside, which is sort of just, here and there, we'll see a wild site every couple thousand miles, pretty expensive. We need sort of a low-cost solution where we just put sensors everywhere. A couple years ago, we started with AEI, and we replaced all those and put it on a common platform. It's pretty much the same platform from a connection standpoint that all the PTC systems are on, and it's unacceptable to have a detector that doesn't send its data in, or for something to be down and you not to know about it, or for your battery to be getting low and to wait until the system dies before you send someone out there to fix it. It's maybe not safety critical yet, but it's getting there, and the regulators are paying more and more attention to this technology, and we try and use more of it to our advantage. But there it is, this standard comms, standard software, and what we've added is a sensor hardware interface. Whatever the sensor is, if it's a camera or a strain gauge or an accelerometer or whatever the next fiber optic, Bragg grading, super awesome ultrasonic sensor looks like, you just plug it in, do a little computing, send it to the back office with those operational goals of knowing where the trains are, the comms reliability, the detector reliability, and have an agility to do research, to try things out, as well as to do the things that are that we think are going to work, that we know are going to work. And so wheel health trending for VSRs and built-up tread is one of the things we think is going to work better than ultrasound, at least effectively, cost effectively and efficiently. And the way that'll work is you'll do an assessment all over the place of a train, and here's what's about it, and you can plug this in and check it again 2 miles later, and 2 miles later, and 2 miles later. So when we look at broken wheels, most of them are found by the carman at a 1,000-mile inspection, which means the average broken wheel is out there for 500 miles. It breaks and it runs 500 miles, and a car inspector finds it. So this type of thing of monitoring more often closes the gap between what the perfect world is with moats in the future, perhaps, maybe, if we get there, if we don't get good enough with wayside, and taking wayside and being able to sprinkle it everywhere. All right. The next thing that no tech discussion would be complete without is talk about machine vision. Same type of idea, some standard wayside thing. For UP, the machine vision is just another plug-in to our wayside systems where everything is done in a standard way and feeds a central location. And here we've just got a few different sensors. It's still some sensors, a computer, send it home, integrate it with all the other data, and tell us what's happening. And now, if we look at the things we're working on, and we do another high-tech capability assessment, our derailment prevention, wow, we can go from having about a 50% gap today to catching almost everything that we've seen or that we can imagine, and in a pretty straightforward way with a fully deployed network, which probably looks like about 70 to 100 locations of this type, in addition with this IoT methodology and some little or specialized things. And as far as doing the work of an inspector, from 28% probably up to 84%. There's things that the technology is just not there for. What are they? Cracks, little cracks, hidden things, of course, as Kim brought up last year when Margaret gave her presentation, and loose things. How do you do loose? Well, we've got some ideas, but the technology's there to bring us to 84%. So, will machine vision take over the world? Because that's what I think you're all thinking, right? When is technology gonna take over the world? And so we got to talk about maybe it's not. Let's talk just a little bit about what this finders to fixers idea is, where you have this idea of automated inspection, and wouldn't that be great? And the reality is that it wouldn't. It would be awful because we don't do inspection and repair today. What we do is triage. We triage every train. Any FRA audit will show you that perhaps there's more out there than you think. But we either do that triage from an inspection or from wayside, and if it's okay to go, great. If you're looking at a train and there's some in-train repair to make, great. But in reality, the things that jump to the front of the list are the really bad things, and you set those car outs, and then any AER write-up guy will tell you that's what an inspection is, right? It's where you crawl under the car. And a typical shop repair, if you are sending this to be jacked, change a wheel set, You'll change 1.5 wheel sets, not really, but average, and do 8 other items and about $3,000. So if you think about it, wow, do we have an efficient maintenance process for trains and cars out there, where you get to set a car out one time, very expensive thing to take this asset, this expensive asset, out of doing its work and have it do the kabuki dance in and out and run across a yard. But you get a 9-for-1 deal. And so if you have the magic super automated inspection device in the technology world, the regulations and the business processes won't support it. You'll send a new car out there and you'll set it out 9 times, where in the past you'd only set it out 1 time. So that's why things aren't moving so fast. But back to the technology. The image and point cloud analysis is what machine vision is. Every one of these things has a great story, all the things that have been done. I'm sure you've seen many examples of different things. It just blows your mind at how simple it is to go on Amazon and buy a thing and another thing and connect them up and go to a website where there's open source software and, with very little expertise, push this over to Amazon Web Services and use Microsoft Azure. And it's the most amazing thing that it took people 10 years to come up with this. And now, in 2 days, you can plug something in and you can have a result feeding your central system to the point where it's in front of the carman or somebody who's assessing how good it is. So the capability there with cars and components, if you want to find a car or a brake valve or a brake shoe or measure this or measure that, first thing is you gotta find it and assess it. And this thing they call deep learning will do that in a heartbeat, and it's about 99% effective. And the measurements, if you're doing measurements, how thick is the brake shoe, or how long is the crack, or how far apart are some things, did your trucks move, is your center plate broken because your trucks are 1/2 inch further apart than they were last time you saw it? Yeah, that's fantastic, and it's just the resolution of the devices, but it's amazing. We've got like those triangulation laser units that they use for looking at chickens, and they use for measuring lumber to get the cubic board feet out of it. We'll get 1/1000th of an inch accurate measurement at 60 miles an hour. Woo! Defects, which is what the end of the line business thing is, they vary a little bit. Got a little bit of variation there, some work to do, but, and on the next slide I'm going to talk about the defects. That's not necessarily a bad thing. I don't see there's any hurdles or any problems with that capability, and I'll give you an example. At any rate, all this technology at UP feeds 2 processes. One is targeted inspection. So that would be like a truck. I want to look at a truck, and a truck, and a truck, and a truck, and I'll go through a little example of that. The other one is an alert inspection. Hey, here's a low coupler, or here's a thin brake shoe, or here's a cracked wheel. For those, you find them and you put them in front of somebody and they assess it and they make, set it out or do this or do that. But those are the two methodologies I'm going to go into. When you think about it, that carman, that inspector who's out there, what's his false alarm rate? It's probably 80 or 90%. You never see it in car repair billing, he's always right. But when you're doing an inspection, how many times does somebody say, I got to gauge that wheel? That's a false alert. He walks over to the wheel and he gauges the wheel, and it's either good or bad. And so he's doing an assessment all day long, every day, through his computer, her computer, their computer. Okay. So is 1% okay? Are 99% false positives okay? Yeah, I think they are. It just depends on the example you're looking at. And so this example is broken wheel. Got an algorithm, and it finds broken wheels every day. On every train, it finds one. It's wrong every time, 365 days a year, 10 times a day, 3,650 broken wheels it found, and it only found one real one for the year. Every time I found one, somebody had to look at an image. It took them a second. That's 3,950 wasted seconds. That's 1 hour, and actually 49 wasted seconds for the year just to find one broken wheel and save $1 million. So really, that guy ought to be being paid $1 million an hour, right? If that's what he's doing. So anyhow, just trying to make the point that this assessment, this is a good thing. Our wheel profile detectors at UP, every single one of those things that's ever been fired, because they're not quite good enough, is looked at by a person. He looks at the pictures and says yes or no. And the machine's 90% effective, and 10% of the ones he calls out, so that we don't waste someone's time down the road. Okay, back to the two paths of machine vision. The targeted inspections, boy, there's a lot of them. I want to look at trucks. And so for this, if there's 100 cars, there's 200 trucks, there's a view of it on each side like this. Some things are covered up, you can't see everything. You only get one angle. The things have to be in focus. But that process might take 10 or 15 minutes. And that can't go on forever. We got 20 cameras, we got 20 or 30 or 40 targeted inspections. And but the path is, on this truck view, I can see the adapters, I can see the cap screws, I can assess the springs, the friction wedges, the wear plates, the side frame, the buttons, the wheels, whatever. And once I've got that done, they no longer look at that anymore. That maybe takes 3 seconds a piece, a half a second if you're looking at like handbrakes, and if you're just handbrake, whoops, yep, that one had a problem. You can do things very fast. But that once you get that automated, it turns into an alert inspection, and you save that 20 minutes on looking at trucks, and you say, okay, now guys start looking at couplers, and they'll do that for a few months until all these things are automated, and that's where we're at. Alert inspections, things like the wheel defects, which may be 99% false positives, or missing cap screws, which is 90% false positives, et cetera, et cetera. And these things take seconds to make a decision. So it's really, really an efficient, effective way to take this technology. I don't think it's going to go away. It's just going to conform and be a way that we do a much better job of maintaining the things at first that are important, the derailment things and the things that are costing outbound setouts, for instance. And with that, some nice graffiti. It's maybe question time, if there are any. If I haven't put you to sleep. Okay, I should have planted a question.
I'd like to give it.
Thank you, Jerry.
How many times do you use technology to confirm technology? An example, like, one reader finds something else confirms that it was accurate. Are there instances like that?
Yeah, the question, how often do we use technology to confirm technology? Well, I mean, it's a great, if you only have one measurement, you don't know what's really out there. The AEI system, we use this technology to confirm that that's right, whereas we used to get to the rip track and the guy would look at the wheel and make sure AEI was right to pick the right wheel. All right, and now we do that mostly time over time over time, because you get 2 or 3 indications for hot box or for wheel profile. Wheel profile detector, there's a thin flange on this end of the car, and at the next one, it's on that end of the car. So we do a lot of that cross comparison between technologies, and you can do that because it's all in the same world, in the same database. Good question. Yeah, also to confirm what you do or you don't know. We started looking at low air hoses or air hose separations, and my gosh, you looked for a month and there wasn't one thing on any of them till we automated it, and then, the bunching effect of the train just happened to show up, and wow, what a difference that makes. So they're really good research tools at this point, and it'll be a while before they find their way really into the mainstream. But there's a big change coming, I think, for getting everybody's heads screwed on straight to the reality that there's a lot of defects out there, and you can't fix them all without getting more efficient and getting some focus and prioritization on the things that are truly matter, instead of treating all 300 things in the FRA CFR as equally important to deal with.
Good. Great, thanks, Todd.
All right.
All right,